Chapter 8 deals with wireless communication technology, and we'll get into a little bit of the technical details on how wireless works and some of the issues around it. So to start with, we need to talk about some of the different ways we can wirelessly communicate. Microwave transmissions are line of sight. So if you look up at a tower and you see a dish up on top of a tower and it's pointed at another tower that has a dish, because it only goes line of sight. Conversely, then you can also have satellite transmission. And we'll look at it in the next slide what these different uh, Earth orbits mean and how they relate to it. But basically, we're sending the signal up to the satellite, and then the satellite is broadcasting that signal back down over a large area of the Earth all at once. And so it gets around the issues like with microwave where you have to have a direct line of sight from one tower to the next. And here's a slide that shows basically when you have the low Earth orbit satellite, it's down here, and you can see it covers a much smaller area than the satellites that are at a farther distance away. Of course, the challenge is the farther the satellite is away from the Earth, the longer it takes the signal to get up to the satellite and then to come back down, and that introduces latency and delay. We'll cover GPS technology in the in-class portion of this lecture. We'll look at a video that goes into a little bit of the technology behind how in the heck does GPS work in the first place. Now, when we're talking about wide area wireless networks, we're dealing with cellular radio. The cell phone became the smartphone, now it's carrying data. And so when people talk about 4G, the question is, what the heck is 4G and what's the definition of it? And what that really stands for, it's a really highly technical scientific term. It just means fourth generation. So every time they come up with a new iteration of the technology that adds a significant increase in the speed and bandwidth, then they call it a new generation. Now what's currently being developed, and they've got some test sites around the country, is 5G. And there's a lot still being done on it. This is not a standard that was developed by the industry that said, okay, everybody's going to, this is how it's going to work. Rather, each of the different phone companies have come up their own version, and they're testing it out, and they'll see who comes up with the best one, who gets to market first, and we'll see if everybody's 5G phone is compatible. To take advantage of the 5G speeds, you will have to upgrade to a new phone. Some phones may be able to be, I don't know if they'll be able to be upgraded in the field, but I think most likely to take advantage of the higher speeds of 5G, you're going to have to buy a new phone. What 5G will allow is speeds that rival your home internet connection on your phone. And that will open up a whole new communications possibilities. This is being particularly done with the driverless cars that are being developed. They need to be able to pass a lot of information. The cars need to talk to each other as they're driving. A lot of data has to go back and forth, and to make that work really efficiently and effectively, when you have more and more of these cars start showing up, they need the higher bandwidth of 5G. So it is coming, it's just not ready just yet. The other thing you might hear a term of Wi-Fi Max, WiMAX, and this has a very long distance, up to 31 miles for the signal. But the problem is it's very slow. And so it needs to, it's useful for some things, but not for a lot of others. I think you're all familiar with the term Bluetooth. It was developed as a way to connect peripheral devices, printers, scanners, MP3 players, cell phones, to allow them to connect. As you see from the photo there, one common way is the hands-free earpiece. You can get cordless earbuds, headsets that are Bluetooth, so you don't have to plug in. They make the connection using the Bluetooth. So here's a challenge. Do an internet search on Bluetooth and see if you can figure out where the name came from. It seems like an odd name when you think about it. Someone had a tooth that was blue colored. So the key here is when you notice the speed, this is very slow in what it can do because it was meant to do really simple tasks. And so it's not a high speed. It works great for mice. I have a Bluetooth mouse that I connect to my laptop. It works great because the amount of data flowing through it is not much, so it works fine. Another thing is called near-field communications. Now this is the shortest range of any of the wireless networks you look at, and it's really designed to where you have to be almost on top of the device in order for it to work. You know, take for example your credit cards that have an embedded chip, and you just tap or get close to the device and it communicates with it. TriMet is using near-field communications. You don't have to insert your card or run it through a card reader. You just go up and get it close to the machine and it communicates with it. Another term you'll hear talked about is a mesh network. And the concept of a mesh network, it's interesting because as you add more devices onto the mesh actually gets better. And because they're building and working together, so this graphic here shows a number of routers, and each router its Wi-Fi can only transmit so far. So it transmits to one, who then transmits to another, and to another. And by working together, this mesh goes a lot farther than it could by itself. Now, this should look familiar because we talked about this in terms of the development of the internet with the nodes and how all they work together. And that's the same concept here, is you're building a reliable network by having a lot of different devices that only have to go a short distance, and they just pass the information straight through. And that's really the way our cellular radio, our cell phones work. The same way, we've got all the cell towers, they're talking to each other. Each cell tower can only transmit a limited distance, but when you go from one to the next one, you can go long distances. Now, another important part, as already mentioned with the near field communications with a credit card, is this idea of doing financial transactions really unplugged, wirelessly. And one example of that is the mobile wallet. And in class, we'll look at a couple of the leading versions of mobile wallet that allow you to do a financial transaction without that same degree of physical interconnection, but actually has some built-in protections that make it less prone to fraud. One of the problems we have with financial services today with business is this idea of micropayments. What micropayments refer to is very small charges. So you want to get a cup of coffee at McDonald's, they currently have where any size coffee is $1. If I charge that $1 to my debit card, there's a processing cost associated that the McDonald's store has to pay. They have to pay to the bank, handling fee. Typically it's going to be 2 or 3% of the transaction plus, say, 35 cents for each transaction. And if your original price was only $1, you can see that eats up a lot of your profit. And so that's been a challenge, and that's why you may see, in some stores where they have a minimum amount that you can use a credit card or a debit card with, and that's because of the cost to process that transaction. Now, we'll cover this in class. There is another way of looking at things. Instead of saying, how can we do a better job of transmitting funds electronically and using credit cards, and it's back, rather old-fashioned, and that's dealing with cash, not using plastic. But we'll cover that in class. Now, another thing that this chapter deals with is the QR code. Now, this happens to be from my resume, and you notice here I've said for samples of my work, to go visit my website, and there it is, www.paulwheatcraft.com, or you can take your smartphone and with a QR reader app on your smartphone, just scan this QR code and it will take you right to www.paulwheatcraft.com. When QR codes came out, a lot of people thought they were going to be great and provide all this, usefulness. Instead of having to type in this, really long website name, all you had to do is scan this little box. Hey, great deal. Well, there's some real problems that have prevented this really taking off. And people didn't understand QR codes and how they work, too. And I'm going to show you a couple of examples now of some people that obviously didn't understand what they were doing. This first one is obviously from a kiosk someplace, and as you can see, the QR code has been broken across 4 different panels. There's no way you can, correctly scan that with your smartphone and have it work. So the person who laid this out didn't understand QR codes at all. They needed to have it, the full QR code, on one panel so that you could properly scan them. The next one always cracks me up. On a billboard. Now remember, it even says right there, it says scan with an arrow pointing to that. That's a billboard. Even if I'm the passenger riding in the car, I've got to get my phone out and try and aim it with my QR, reader app at that while we're moving where it's up in the air. And is that ever going to work? I don't think so. So again, an example of someone who did not understand what QR codes were and how they worked. But this next slide I'm going to cover really shows you why I believe that QR codes did not take off. So this appears on a brochure, marketing piece, whatever, and it says click here to get more information about our product. Can you tell me where that is going to take me? What website is that directing me to? And the answer obviously is there's no way to know where it's going to. Now this is a real QR code. I used a QR code generator to create this, and I'm going to show you now what website I told it to go to. Now the website I told it to go to is a fictitious website called badguysite.com. And so, as we've talked about, not clicking on links that you don't know if the site is trustworthy and so forth, that's the real problem with the QR codes, is you're taking a leap of faith. The only time I use QR codes, some software companies will include a QR code when you buy the product at the store. There's a QR code in there to register your device, and that can be safe because you're going, okay, I bought the sealed package, although it wouldn't be impossible for a criminal to break the seal and replace the QR codes in the package. Or I've seen the QR codes put on the sticker that's on a product. And so when you're setting up, configuring one of your Internet of Things devices to be on your network, sometimes there may be a QR code that you can scan, and that will automatically make the connection. Again, I'm not really enthralled with that approach because I don't know for sure that it hasn't been altered and that somebody hasn't put a malicious website on that instead of the correct one. I've talked about this several times in class. Business people, we sometimes get kind of crazy with our language. Pervasive computing, or ubiquitous, I can't even say it, computing. This is the Internet of Things, that we've got, connections embedded in devices, in objects all around us, even in things that we wouldn't think would have a computing device or communication device embedded in it. So it really refers to all these devices that are embedded around us. And we'll see more in class. I'm going to show you on a slide now here. This is an RFID chip. And to get an idea of the size of this, with all these lines you see on that, actually all the lines that you see going around there, those are the antenna that allow it to communicate. The actual circuitry is this part down here. And the size of it, of this whole device, you can see is pretty small, and it's very thin. And so it can be put anywhere. It can be put in the collar of a shirt, sewn in. You wouldn't even notice it's there. It can be put in the heel of a shoe, and you don't know it's there. Now, the one thing you'll notice about the RFID chip is there's no battery on it. There is no power to it. We'll talk about that in class. So how does it work if it has no source of electricity? We'll take a look at an example of using this in a supermarket, where you can use RFID chips that have been embedded in the food items to automatically do your checkout. And this is different than barcode reading, and we'll talk about that in class as to what's the difference between an RFID chip on a product versus the standard barcodes that we're all used to. Now, we can't finish up this chapter without talking about security and the dangers. As we've talked about in class and have mentioned before, these dangers with wireless communications, we have four major threats. One is that you can have a rogue access point. And what this is, it could be a van, a car. They drive around and they park outside, let's say, the Hilton Inn. And they know the Hilton Inn has a wireless network. But what they have is a really strong wireless network. And so they will name their network Hilton Inn, or they might Name it something, like Hilton Inn high speed. Uh, and then they will, because they're more powerful, the way most of our computers and cell phones are set up is they will try and connect to the strongest Wi-Fi signal. And so they will take and make their signal look like the legitimate Hilton Inn Wi-Fi network name, but they will be stronger so that you make a connection to them. And of course, then anything you type and send, they have access to, and they turn around and then pass it. They connect to the Hilton end. And so you don't know that there's someone in between you. Everything seems to be just what you would expect it to be. The other, really the fourth item there, RF radio frequency jamming. This is where someone can come with a strong transmitter, and instead of wanting to tap into your system and read what you're doing, they want to prevent you from having any access. And so they can create a signal that's so strong and scrambled that it swamps out your wireless and you can't get anything through. Think of it as just like with the DDoS attack, where you prevent someone from accessing the internet. This is the same thing with radio frequency, with the actual wireless waves that are used to transmit the information. You can block it by having this really powerful transmitter. The war driving just refers to you drive around a city and you've got a device that's listening, and so you're locating where all the different networks are, and that's so that you can take action, like with the rogue access point or with the jamming. And eavesdropping is just what I already talked about with the rogue access point. Once you get connected to that by mistake, then a person just listens to everything you type, including your financial bank, your account number, your password, and so forth. So as I mentioned, we'll cover these in more depth with some of the videos in the class, and that wraps up for right now for Chapter 8, and we'll talk more about it.